Hello, everybody, and welcome to this webinar, the third webinar in a series of uh, information on the milk taxi. No chance for germs, that's the title of today's webinar, and we would like to talk and discuss about the effects and the benefits of pasteurizing and how to manage this with a milk taxi. So very often we get the question of, why is pasteurizing important? What are the necessary procedures, and how are we actually to work with the milk taxi when it comes to pasteurizing? Very basic question: why is milk cooling so important after pasteurization? So here we have some answers as well, and very practical points like how to set the automatic start times and how to use hot water in order to save some energy cost in the milk taxi. So yeah, welcome to this webinar, and I think we just jump right in. So what happens during pasteurization? Pasteurization is a heat treatment process. And heat treatment means so we warm up a certain amount of milk to a given temperature. In this case, we are talking about 60 degrees. 60 degrees temperature, which we have up here, or actually it's 63 degrees in this example. So we need about 2 hours to get that amount fully filled milk taxi to that desired temperature, keep the temperature for half an hour, and then we're cooling down the milk. So what happens inside the milk? So of course we have some bacteria inside the milk, and here was what happens with them during the heat treatment. As you can see, E. coli bacteria, they're very susceptible to heat treatment. Already with a temperature range of 40 to 50 degrees, we are killing most of the E. coli's. And even before we are reaching the pasteurization temperature, this amount is the level of the bacteria is down to zero. But we have some other bacteria who are a little bit more of a concern, which are Enterococcus or Staphylococcus, like Staphylococcus aureus, for example, which you probably know as well. And so here you can see that they actually like heat. So they like temperatures from 30 to 40 degrees, and you even see how rapidly they are growing here in this first hour. But as soon as we jump above 50 degrees, you can see here that both of them are being reduced significantly. Enterococcus as well, like with E. coli, before we're reaching the 63 degrees, we don't find them anymore. But for Staph aureus, we need to have the 63 degrees. We need to have the time in order to kill them completely. In reality, we don't need the whole half an hour for pasteurization. Normally, they die within the first 10 to 15 minutes in this period. But it's most important to know that at the end of the pasteurization, they are all gone. So that seems to me pasteurization is doing a really good job. But it's not 100% like that, because there are still some bacteria who remain alive. The so-called spore formers, they somehow protect themselves against the heat treatment, which we do with a milk taxi. So we see a slight decrease in the population, but it's not really a lot. And so these bacteria still remain in the milk. But they are of no concern, because they don't create any disease in cows, they don't create any disease in calves. So they are not troublesome for us. But they do one thing: they can make the milk go off if we don't cool it down rapidly after pasteurization. So if we would just let the milk sit on 63 degrees and let it cool down at the air, so these spore formers will start to grow in population, and they will make the milk go off. So they are basically the reason why we need to have the rapid cooling after pasteurization. So, and then of course rapid feeding of that milk. So you see, so different bacteria have different developments here during this pasteurization process. So there are different ways to pasteurize. Like I said, the batch pasteurizing, what we are talking about, 63 degrees, 30 minutes, that's basically what we are doing with the Milk-Taxi. We are killing all Salmonella, we are killing E. coli, Staph aureus, Mycoplasma, Leukemia virus, and so on. So we are very safe here on this side. There's another system available, which is called flash pasteurization. So with 75 degrees Celsius, 15 seconds. So higher temperature, much shorter time. They do the same job. So the result is exactly the same. We just have two different principles. So, and the flash pasteurizer needs a little bit more technology. So here we have an example how this would look like. For example, we have a large pasteurizer here, a medium frame from Calfstar. And in this example, in this picture, you can basically see the principle. So you need to have a raw milk tank which holds your milk from your cows. The pasteurizer is pasteurizing the milk and then delivering the milk to the receiver tanks with the pasteurized milk, ready to store the pasteurized milk. You can see this here in the scheme, for example. So there is a heat exchanger at the entrance. So the cold water gets in, and the cold water is pre-warmed here in the first heat exchanger. And then the pump is pumping this like 40 degrees Celsius warm milk into the second heat exchanger. And here we're bringing the milk up to 70 degrees Celsius, 15-20 minutes, depending on your program. And then the temperature, milk is kept on that temperature before it's being cooled down here in this first heat exchanger. And this is the beauty of this system. So we are actually recovering the majority of the energy which we are putting into the system. So we are using the heat energy from the pasteurizer to pre-warm the milk which goes into the system. So flash pasteurizers are a very energy efficient procedure. That's different to the Milk-Taxi. In the Milk-Taxi, you heat up the milk at the beginning. So you're using a lot of energy to do that, and then you're cooling the milk afterwards, and there's no chance, no possibility to recover that energy. Is that a big problem on the Milk-Taxi? Sometimes people ask me, okay, what are the energy costs involved? And I can tell you that we normally calculate with about 1.5 euro cent energy cost per liter of pasteurized milk. So when we have 150 liter Milk-Taxi, we're talking about 1.5 euros to pasteurize that milk. So 1.5 euros energy cost to pasteurize that milk. If you would have this, if you would like to fill that this 100 liter milk, if you would like to replace this with milk replacer, then your total cost would be, if we just take 15 kilogram of milk replacer multiplied by 2 euros per kilogram, so that's roughly 30 euros cost involved. And if we just consider that this milk being non-saleable milk, the whole milk which we are pasteurizing for €1.50, you see the big difference. So €1.50 energy cost compared to €30 milk replacer cost. And for these €30 milk replacer cost, you also need to add some energy to get the water temperature to the right level. So that so there also you have another €1 probably for energy involved. So the milk taxi is a good option to this flash pasteurizer system. So where is the break even? I would say if you need to pasteurize like 400, 500 liters of milk per feed for your calves, then you could start to think about a pasteurizer system. I know that Calfstar has different machines available, different sizes, so probably that's a good idea to discuss with them what are the basic needs for the given circumstances on a dairy farm. Okay, so what is the are there any downsides on the milk taxi and any negative effects? Yeah. So what would we call the limitation of pasteurizing? If we really have really bad milk quality, so milk with lumps, very poor quality, with blood clots inside, milk which doesn't smell nice, and so on. So I would not pasteurize that milk, and I would not feed that milk to calves at all. So really bad quality milk, you are not able to improve that just by pasteurizing. Milk concerning medicine like antibiotics, I would not feed that to calves as well, because with pasteurization we are not able to inactivate the antibiotics, and still the risk of resistance of bacteria, and you would not like to have a resistant bacteria in your farm, which is not which you cannot cure anymore with the bacteria you have with the antibiotics you have available. So that would be a really bad situation. Colostrum and global lines here. We have some limitations. Should not be pasteurized at too high temperatures. So 63 degrees is already too hot for the global lines. Here we recommend to use a different pasteurization procedure, 60 degrees, 60 minutes. I will just explain this in a minute how that works. So that's something which we need to consider. And last but not least, I know it's discussed a lot, paratuberculosis or Jones disease. I know that some of my colleagues are quite optimistic about that, and I know that there are at least a dozen research which show that Jones disease can be eradicated from milk by pasteurization, but there are also a few research which show that the level of killing of these bacteria is not really 100% guaranteed. Sometimes when you incubate that milk, paratuberculosis bacteria, they pop up again. So we need to be careful. I would not use milk from positive cows, but I would pasteurize milk of all the other cows just to get to be on the safer side here. Okay, so how does it actually work in a milk taxi? Let's have a look. So here you can see a screenshot on the Calf Guide where we can monitor the procedure, and you can see Calf Guide is monitoring the whole heating and pasteurization phase on the milk taxi. So we have about 80 liters of milk here inside, and we need about 1.5 hours to get it to the right temperature, 30 minutes on the temperature, and then it cools it down again to 40 degrees drinking temperature. So the milk taxi is doing all this for us. Yeah, so that's if your milk taxi is connected to Kafka, you have a very nice overview of every individual pasteurization. So you can even trace back multiple days or even weeks and see if all the pasteurization cycles have been worked out nicely. So how to set the pasteurization features in the milk taxi, in the menu. And if you have been on our other webinars, so you know that I'm showing some videos here. You need to add your code 683 to the menu, and then you go down to the pasteurization program. And here you're basically able to choose amongst the different pasteurization programs. So here 63 degrees, 65 minutes, or just by pressing the OK button, you're moving from one program to the other. You can go to the 60 degrees, 60 minute program as well. So first choice you need to do is choose your pasteurization program. The second choice is if you would like to have automatic start of your procedures, you need to program your start times. And this is how you do this. You just go down to timer, and then you are able to choose your different start times up to 6. And so that's the start time for the heating. But you go to the pasteurization, and you can see here right now the pasteurization is shut off. Now it's on. In this program, supposed to start at 3 o'clock, and you are able to change that to 5 o'clock just with the keys. Straightforward. Here you see a different menu. There's another possibility when your milk taxi is equipped with Smart Mix. Then you are able to not only to program your start time of the heat, but also the end time. And this is really practical because here you just need to tell the milk taxi, look, at 6 o'clock, I would like to start feeding. Or in this case, at 7 o'clock, I would like to start feeding. And the milk taxi will know exactly when to start heating to be ready at 7 o'clock. This is only available if you have the Smart Mix feature in your milk taxi. So standard comes just with start temperatures where you need to calculate your time, and the end timer with Smart Mix. So, and that's basically the rather easy way to work with this system. So, how to connect your water connections. You see here that your milk taxi with the pasteurizer comes with a cooling jacket, which is outside, and you need to connect your cold water connections, cold water in, cold water out. Quite straightforward. Just don't forget to open your water flow. There's a valve inside which would interrupt the water flow if it's not needed, and it will open once this milk taxi starts to cool. Very important is that you don't limit the milk flow after the milk taxi. So the outlet, we need to have a free-flowing outlet of the water flow. Sorry, not milk flow, because the milk taxi can handle only maximum 1 bar water pressure inside. So if you limit the water flow on the outgoing side, that can be higher, and that can cause damages in the milk taxi, or there's some security valves inside the milk taxi which would open, but that's not what you want. Okay, so how do we start the cooling feature? And that's basically a very simple simple procedure. You just press the button here and it will start to cool. And you have the choice to change your cooling temperature here just with the flash keys up and down and just with the OK. So since that was rather fast, I'm just showing this to you again. So start cooling here. So that's a manual process once you filled your warm milk. If you would like to change your cooling temperature, just use the up and down keys, confirm with OK, and yeah, you should be on the safe side. So I think now it's time to discuss a little bit what is the best temperature to store the milk at. So in your dairy, you should store your milk just above freezing, like 2, 3, 4, 5 degrees Celsius or whatever. Here in the Milk Taxi, that's not really necessary. Like I said, we're just using cold water for cooling, and we've chosen for cold water because it's a very, very simple system. Not a lot of electronics, no cooling agents, and nothing necessary. But we are also limited to the temperature of the water with this system, which is not a big problem because we know that as long as the milk temperature is below 18 degrees Celsius, we are able to store the milk easily for 10 to 12 hours without any real severe bacteria development. Only after that period, or if the temperature is higher, then we see an exponential growth on the bacteria. So as long as we keep the milk temperature, let's say below 18, 20 degrees, we are on the safe side. Here in this example, you see 13 degrees. Why is that? The water temperature here has 10 degrees. And we recommend to set the desired storage temperature like 3 to 4 degrees above the temperature of your cold water. Then you still have a good result on a good efficiency of your water to cool down the milk. So how long does it take and how much water do we consume? That's a question we are always very often asked. And I would like to explain that to you here in this calculation tool. In this example, we have a 150-liter Milk Taxi, which is filled with 80 liters of milk. Yeah, we can see here that it takes about 1 hour to get from 15 degrees to 63 degrees Celsius. And we have two curves here. So one curve is cooling with 10 degrees and a water flow of 15 liters per minute. And then we have another an example. Again, here the same temperature, 10 degrees Celsius, but with 5 liters per minute water flow. And that's very important. With a lower water flow, we have a longer cooling process. So it takes about 5 minutes longer to cool the milk with less water flow, which seems to be normal. But the water consumption is significantly less, as you can see here in the bottom. So we have 263 liters with a 15-liter water flow, and we have 110 liters with a 5-liter water flow. So same milk temperature, same amount, but we have less than a half of the water consumption. So here in this example, so for 80 liters of milk, we need 110 liters of cold water. And that's what we would normally recommend. Try to keep the water consumption to 2 liters per 1 liter of milk in your tank, and you can easily regulate this with your water flow, because very often you are not able to reduce your water temperature here. If you're able to use ice water, that's even better. It will be faster and consuming much less water, but that's depending on your local circumstances. So here's my recommendation, more or less at the end of the presentation. Try to reduce your water flow as good as possible. Okay, But yeah, at the end, last but not least, we also have a possibility and a feature which is not really used a lot, but should be used, I think, because we are able to save a lot of electricity, a lot of energy by equipping the milk taxi with a hot water heating. So we are able to use the double wall tank not only to cool the milk with cold water, we are also able to equip the milk taxi with a feature, with a warm water heater, where you're able to connect your warm water connection. If you have a surplus of warm water from your milk recovery, from your biogas plant or whatever, and a lot of farms have surplus of water, of hot water. So you are able to use this here in the milk taxi to pasteurize the milk faster and much more energy efficient by saving a lot of electricity cost here. So very good way to work or to use the possibilities of the milk taxi. And now, really, at the end of my presentation, I come to the question: what is the button for here on the screen? We didn't talk about that. So the pasteurizing button on the screen is actually just there to start a manual pasteurization. That's it. So you press the button and then it will start this example, so pasteurize immediately from 35 degrees going up to 63 degrees and on pasteurization temperature, and then cooling down after 35 minutes to 40 again. So, and that is basically all the magic behind this one little button there. So if you don't rely on your automatic start times and you like to get up at 3 o'clock in the morning, yeah, just don't forget to press that button and it will start to pasteurize your calf milk.